Excellent. Well, hello everybody again.
Hey, David, we can't see. You plan to turn your video on if you can.
All right. Hold on one second.
There we go.
Can you see me now?
Thanks.
All right.
Yeah.
I've got my favorite Mojaloop shirt from I don't know, 4 convenings ago. Anyway, actually, you said that it's going to be me presenting, and it's going to be James and myself presenting this. And James is going to start off. So I'm going to share the slides, and James is going to start. And James, are you ready?
Born ready. So hi everybody again. David and I are just going to talk a little bit about the work that's been going on in the on-prem work stream. This piece particularly focused on the infrastructure as code. So there is a volume of infrastructure as code in the Mojaloop GitHub world. Historically, it has targeted production quality deployments in AWS cloud. When we kind of realized that we should be focusing on on-prem for reasons that I mentioned earlier, there's lots of people queuing up to do on-prem deploys for larger scale Mojaloop implementations. How do we support that? How do we help that? One of the options we've been looking at is extending the IAC, refactoring it, so it can also support on-prem deployments, possibly with a number of flavors going forward. David, would you like to move to the next slide? Thank you. So before I hand over to David, I just want to recap what we think some of the requirements are for doing on-prem deployments. These are relatively high-level requirements. There's a lot of detail hidden under most of these. Too much to go into here, but I hope you get a feel for why we're doing what we're doing. So first of all, we think there should be a complexity level scale. IAC can be a complex world. There are lots of different tools and techniques to deploy what is a complex ecosystem of software products into a hosting environment to make them work together as a switch. There are various levers that can be pulled in that process to simplify the amount of upfront thinking and planning that has to happen. And we think it's important that adopters can start simple and only get into the nitty-gritty complexities of the underlying tool chain and the deployment configurations as they require more customization, more flexibility, more specialization for their own particular needs and use cases as they discover them along their Mojaloop journey. However, the bottom end of that needs to be low cost, low barrier to entry, but there also needs to be a path for people to move up that complexity scale. So assuming you choose a simple, relatively hands-off deployment process on day one, shouldn't mean you can't do more complex things later on. And the way you get from simple to complex should be well-defined and straightforward. You shouldn't need any special things along the way to make that happen. We do think that adopters should have the ability to take full ownership and stewardship of their platform. That's kind of one of the core principles that I think everybody in the Mojaloop community could get behind. That vendor lock-in is a bad thing. We want people to own their own destiny. Owning your own switch from source code all the way through to hardware is something we want to encourage. So everything we're doing has that in mind. We want to use the most widely known and well-supported tool chains. We don't think people should have to learn a large number of difficult esoteric skills. And those tools should be the kind of thing that would be acceptable, supported, used quite commonly in any kind of typical major financial or government organization around the world today. We want to make sure that the deployment artifacts and tools that we provide include excellent documentation. We truly believe that in order for adopters to have that stewardship and long-time total ownership of their platform, they need to be able to understand everything to the last nuance of detail about what it is they've got. However, having said that, we realize that for a lot of people it's going to be a journey, and they might not start having those skills in-house. So we do recognize, and the work that we do tries to recognize the fact that at certain points of the process it might be appropriate for adopters to hire or procure external maintainers or support commercially as might be appropriate. Running a mission-critical production-grade piece of national infrastructure is quite a daunting task for many organizations, and especially if it's a new platform you're bringing into your organization, you might sleep better at night if you had the knowledge of a solid support organization that can help you. So nothing we do, nothing we produce in this work stream will preclude that. Okay, so I think I've just laid out the basic tenets of the work that we're doing, and I'll hand over to David at this point to talk a bit more detail about what's been happening.
Thank you, James. So as James mentioned, there's been IAC modules and in the Mojaloop GitHub org for quite some time. And those are AWS specific. And there was some work done a couple of convenings ago in order to make that cloud agnostic. So we did go down that path a bit. But in order to fully support a more modular approach to the IAC that would support on-prem and managed Kubernetes clusters, as well as do-it-yourself clusters, the code was refactored to better support that model. And so there's new repositories have been created, and I just wanted to point out that it is not an evolution of the previous IAC. And the IAC that I just mentioned, the AWS specific, is still being developed, and it's still being used for releases of the latest version of Mojaloop, et cetera. But what I'm talking about here is the refactored effort. So what we wanted to do here is create modules that could be used in a plug-and-play fashion based on, as James mentioned, the end user's particular goals, right? And those could be in line with an open source setup with some modules, and maybe they want to use some proprietary modules elsewhere. But the whole approach should be pluggable in that sense, so that we don't preclude the maximum reuse of the work that goes into modules that are general purpose. And we are starting off with a bunch of assumptions about what we're building IAC for, and we're going to get to that in a following slide. But what we want to do is build out repeatable infrastructure for Kubernetes clusters, as well as the application tier. And the structure of the IAC is reflecting that approach, that philosophy. So code-driven deployments, they have to be repeatable. And they should be completely automatable. To Tom's earlier point about operators being a model, this is something that is used throughout the existing IAC as well as the new version to take advantage of all of the benefits of the operator model that Tom talked about earlier. And the whole premise of using an IAC approach is to give an increased confidence to the operators to be able to make changes without being frightened of the results, because they are constantly making changes in production. And so those minor changes that keep people up at night cease to be a problem, because you have a repeatable way in which you can deploy those changes. You've tested it throughout your lower environments, and you test it constantly throughout production. And so then you are able to adapt to changing business requirements because you're not afraid of making a change in production. All right. So as I mentioned earlier, what are the assumptions behind this approach? Well, first of all, Mojaloop should be deployed on Kubernetes. That's a primary assumption. We're not trying to make use of other say Docker, Compose, or Swarm, or any other workload orchestration technology. We are just focused on Kubernetes. I think that that's a pretty sane assumption given our work to date. But I just want to lay that out to begin with. And then secondly, we want to point out that having a private cloud, let's put it this way, requiring a private cloud technology to be installed is too much of a burden for an operator. And we should definitely not require that private cloud technologies such as OpenStack be used, because it's going to provide minimal value and it's going to introduce a lot of additional technical complexity for the operation of a Mojaloop switch. So if an operator just wants to run Mojaloop, they shouldn't have to be, in addition, having to operate a private cloud and all of the operational complexities that choice would bring. So this will become clear in the further slides of how we're suggesting that that Mojaloop deployment should happen in an on-premise situation. So we feel that all of the components that we produce as a part of this IAC effort should be completely open source. And there shouldn't be license restrictions about how those components are used. And as I mentioned earlier, there should be pluggable options for commercial replacements for those open source tools, but we should not, as a general principle, bake in any commercial components into the IAC that we create. And these are opinionated assumptions, and people can feel free to disagree with those. But I'm laying out some of the arguments as to why they're important, and I feel that it's the best way forward to make sure that we have a reusable solution for as many adopters as possible. So regarding the actual Kubernetes cluster that we build, the deployment of the Mojaloop solution should use consistent tooling, irrespective of which cloud provider or Kubernetes distribution that we use. And in addition, what's the hardware that's on-prem or in the cloud? So we should have consistent ways of deployment that allow us to hide the fact of how the Kubernetes cluster was built in the first place. And that will allow for the most reuse in terms of the IAC that deals with the application deployment. And then the deployment templates, we should have same defaults that we're providing to the community so that they can provision Mojaloop and the open source versions of the other components. And those other components are what provides logging, monitoring, security, operational capacities. So those should all come with same defaults as a part of the IAC that handles the deployments. So in terms of the second item that I discussed in the previous slide, no private cloud. I don't want to spend too much time on this, but these slides are going to be uploaded, and I'm happy to field questions or have further discussion on it. But essentially, what it boils down to is Kubernetes is a workload orchestrator. And so it is essentially virtualizing where your workloads are happening. And then to add on the back of a switch operator, also the requirements of running cloud. And cloud doesn't mean just virtual machines. Cloud means a bunch of APIs that provide object storage and provide networking services. And so there's a lot of overhead to maintaining those services for minimal gain if you're not running a private cloud already. So to be clear, if an operator is already running private cloud services, we're not saying they shouldn't run Mojaloop on top of those. That's definitely a valid use case. But if an operator, all they want to do is run a Mojaloop switch, then what they need to do is run a Kubernetes cluster and then deploy Mojaloop on it in the simplest terms possible. And we're saying, don't increase the complexity of your work by adding something that doesn't provide you any benefits towards operating that Kubernetes cluster and Mojaloop by also introducing private cloud technologies. So I'll leave it at that. Well, I guess I didn't leave it at that. So this is a diagram, and I don't know how well it comes across on your screens, but just to show in terms of the onion layers, when we're dealing with public cloud, when we're dealing with Kubernetes on bare metal versus if we are requiring private cloud to be installed as well. And obviously, the difference between public cloud and private cloud is that all of these other layers in the onion are being handled for you by the cloud provider. And therefore, that's the benefit of going with a public cloud. But if you compare these two, then the obvious choice is to reduce your complexity by limiting the layers of the onion that you actually have to operate. Okay, so we went through the assumptions. So if we take that as a given, what is the best way to provision and manage a fleet of hardware to accept, operate, and maintain a Mojaloop switch? So we're starting off with no surprise that IAC is the first item. So why do we think that IAC is necessary? Because it's going to drive operational consistency, simplicity, and repeatability of infrastructure, the deployment of infrastructure, which will minimize downtime and maximize compliance, auditability, and security. So I think I already talked about IAC and why it's, I don't think I need to belabor the point of why we're using IAC. GitOps, this is more interesting, and it does touch on the operator pattern because GitOps, in essence, is an operator that is constantly looking at a GitHub repository or repositories as the source of truth of what needs to be deployed into a Kubernetes cluster. And it keeps the cluster in sync with the desired state. And that desired state is committed to a repo or a series of repos. And this prevents configuration drift. And also, if somebody got onto the cluster, made some unintended changes or intended nefarious changes, those would get completely wiped within a minute or whatever the cycle is of the operator. So the GitOps, again, is an operator, and it is making use of your source of truth in order to keep your Kubernetes cluster in sync. All right. And so what we want to do is, but we're going to talk about the different technologies that are going to be used for each of these categories. But we want to use a modular approach of the community cloud-centric IAC approach from earlier, and we want to modify it in order to become more cloud agnostic, more modular, so that pieces can be replaced as appropriate. And we want to leverage all the work that went into that AWS specific IAC. And in summary, the important parts of the existing AWS focused IAC are the use of GitLab as a repository, as well as CI/CD. So that is a crucial part of the solution, because as you notice within the GitOps pattern, we need to have a repository which is going to reflect the state that we want the cluster to be in. So GitLab is going to fulfill that, and it will also fulfill the CI/CD process through its runners. And we also want to have the ability to use container and Helm chart registries that are private. So GitLab also provides those technologies in combination with Nexus, which is another open source tool that we were using in the previous AWS IAC. VPN capabilities. So I want to make sure that I don't confuse the reason for having VPN. So we don't expect any of the DFSPs to need to use a VPN in order to control to access the switch. There are other security capabilities that we use in order to control access, such as mutual TLS and IP whitelisting, et cetera. But the WireGuard VPN is referring to the operations access to the control plane and the environments. So this is for accessing the VMs or the bare metal that the Kubernetes nodes is running on, as well as the GitLab server and any of the other nodes that are a part of the control plane or the environments. So the WireGuard VPN, we are setting up a mesh VPN between the control plane and the environments to allow for that operational network access, not for actual data traffic. So object store, an S3 API compatible object storage. This becomes a requirement when you use certain tools that are expecting or have expected in the past to use S3. We're using Seaweed FS as a open source solution to provide an S3 API for that object storage. And then something that we added recently is a Vault, HashiCorp Vault instance for the control plane. So this serves two purposes. One is that for secret management within the CI/CD, GitLab Runner is able to, has an integration with Vault to allow you to store your environment variables that are secrets in Vault, and then access those within the CI job in a very seamless way. And it also allows environments that are built to access those sensitive informations as well from Vault. And the second thing is that each environment owns its own vault with its own secrets that the control plane shouldn't see. However, the vault for the environment needs to be auto unsealed, and we can use the control plane vault as a auto unseal function through the transit engine, and that's also the second purpose of that control plane vault. And I should have started with this one before here, the compute being discrete from control plane. I should have talked about that from the beginning because it's important. The existing AWS IAC built the tenancy on GitLab and a lot of the same technologies that are mentioned on the left side there. But it also built out a VPC for those components that was shared with all the environments that the tenancy would build. And so this quickly became untenable because as you're building environments, you might want to build one on some AWS VMs. You might want to build the next one on bare metal, and you might want to build the next one using EKS. Or you might want to run them on Azure or GCP. So the control plane is providing APIs to be called. And as I mentioned, there is a mesh network of WireGuard that allows access for the management plane for those environments to talk to the control plane. So essentially, in this new version, we're breaking the old model of the same VPC owning the network, subnets, et cetera, of the environments that it supports. And now those are, as I mentioned, you can build any cloud provider and could be managed Kubernetes or do it yourself and on-prem as well. And they all interact with the control plane in the same secure fashion. So that was a major reason why the old code needed basically we needed to start over. So I'm going to quickly go through these. The control plane I've already mentioned, and this kind of goes into exactly what benefits each of these components provides. And I think I've talked about all of these. NetMaker is the meshed WireGuard VPN tool that I talked about. There is a little bit of concern regarding NetMaker in terms of the long-term viability of it as an open source solution. It's completely open source now, but I do see that their focus seems to be headed towards a SaaS offering. So we may consider some alternatives in that space. And outside of that, I think I've talked about all of the different components and what they provide in the earlier slide. So let me switch over to the Kubernetes environment infra, because again, what we're trying to build is an opinionated Kubernetes deployment that can be deployed on any infrastructure and with sufficient customization capabilities to allow the actual code that provisions these components not to care what kind of Kubernetes cluster or underlying infrastructure they're being deployed on. So those various components are external secrets, and external secrets is an operator that allows the creation of Kubernetes secrets based on different providers such as HashiCorp Vault, GitLab variables, all the different cloud providers and their secret store solutions are implemented there as well. So it at a bare minimum, it allows us to seed certain information into Vault and have that flow through as Kubernetes secrets using the operator. Certificate manager. This is to provide TLS certificate management for different ingresses. Vault. So I mentioned that each environment has its own HashiCorp Vault instance. So environment secret data is being stored there. This also, in conjunction with a config operator for Vault, allows us to have zero-touch maintenance of random passwords. So nobody ever sees the password. It gets created in Vault, and then a Kubernetes secret is generated from that. And then all of the deployments reference those secrets. And so nobody ever actually sees the credentials. The UI for Vault is auto set up for authentication via OIDC back into GitLab, which is another feature of GitLab, which is very nice. And then I also mentioned earlier the auto unseal via Transit Engine on the Control Center's Vault. So that's how we're able to remove all cloud-specific key management service dependencies. Anyway, I'm going to leave it at that. Longhorn is what we're using right now for storage for persistent volumes. And this is hosted on node attached storage, and it's replicated across multiple nodes. So we've used this for quite some time. Going towards the future, where we'll be looking to use Seth, and I will put some notes about long-term changes before I upload this document to GitHub. So we'll give some future direction notes where appropriate. Argo CD. So each Kubernetes cluster has this operator that is running, and as I mentioned, is syncing the cluster to the source of truth, which is residing in an environment specific repository in GitLab. And so when the cluster gets provisioned, it's provisioned with a hook back into GitLab, and it pulls everything it needs from GitLab, as well as I mentioned, the tenant vault. Loki Stack. So Loki Stack is from the Grafana people. It includes Prometheus, Loki for logs, and Grafana, among others. This Grafana instance also is auto set up to support GitLab OIDC, and dashboards can be pre-configured and added to the repository for viewing whatever you're interested in that regard. And then another item that is going to change in the near future, we use Ingress Nginx, and that is providing mutual TLS support and IP whitelisting on top of its just Ingress controller functionality. And we set up two, one for internal and one for external traffic, to allow traffic to only be accessible over the WireGuard VPN. So if you wanted only to allow Vault and Grafana access over the WireGuard VPN, you can choose that. And the note on the bottom there, we want to move to Istio in the future. And you note that I have said nothing about API Gateway. Well, I've said nothing about WSO2. And the idea is to already move to Istio before and use that for ingress as well as API Gateway functionality. But that is a yet to be designed addition. All right, so how is this delivered? The repositories are in the Mojaloop GitHub org. We have GitLab CI templates which are CI jobs that are pre-built, regardless of what the underlying infrastructure or the type of Kubernetes cluster that you're building, they're the same. So the Terraform templates, those are built out for various cloud vendors. And then there's also modules that are completely cloud agnostic. And a combination of those Terraform templates are used to build out the infrastructure. And then there's Ansible collections, and those provide the roles for building out the nodes, both for the control plane as well as for the Kubernetes nodes, and the bastions, and essentially the components that will be talking to each other over the VPN as well as over the internet, and the other collections are used in order to install Argo CD and some other packages that need to be there as a part of the Ansible installation. And those are also a part of that collection. And then the last piece is the Argo CD application templates. So these are templates that are used to actually parameterize a deployment of all the components that I mentioned here. So some of these components will have cloud-specific data that they, parameters that they need to support, and a lot of those will be configured using Vault in the control center and pulled in at deployment time. But there is, in these Argo CD application templates, there is the code for building out all of those different deployments, and as well as the Mojaloop deployment. And whether that Mojaloop deployment happens as an operator or happens as it is now as a Helm chart, that doesn't matter. It's the Argo CD application templates are a combination of custom resource deployments as well as Helm charts. Okay, I already talked about the GitOps deployment model, so I'm not going to revisit it. And I think I'm going to finish it there for any Q&A. I don't know if we have time. And also I put the repositories that are being actively developed. They are subject to rapid change. So I will leave it there. Simeon?
Thanks so much, David. We have got time for one question. I know Miller had a question in the comments, but I think James has settled that. But if anybody wants to voice a question, I can take just one. You can use the raise hand function. Miller, I see you on mute. Did you want to chime in here?
Oh, I wanted to be sure somebody else got a chance. I do have a final question if there's time for it.
Why don't you go ahead, Miller? But it needs to be a short one because we're just 1 minute away from the next question.
Of course. I think it's very good to see these pieces come together using these different parts. The Longhorn sounds like a really great tool for managing the secondary storage. The questions that arise, I think, are how we articulate this environment out to the others. In particular, the HSM support is pretty much a requirement in any kind of banking context. And it seems to me that may become only a paid option for the tools that we're looking at. I wouldn't say that that's an emergency right now, but it's something that we have to be very cognizant of, that we say, here's all of the stuff running, but by the way, when you deploy it, you're going to have to use the enterprise versions of everything. And we wouldn't want that to creep up on us. So let's monitor that. I think that PKCS number 11, which is a standardized API for the use of HSMs, already separates a particular API from an HSM from what you would need to use in this kind of environment. And I would think that most of these deployers are going to want to be looking at that kind of capability. And there's a sliding scale to how big those things are. They could be giant rack-mounted things down to USB sticks. But I think it's a key part of of working this out is to be sure that we've got good secrets protection, even though we're using soft crypto in the way you've described, which is very, very efficient. You do want the master secrets and other things stored in HSM. I think that's just a more of a comment, I guess, at this point. Thank you.
Yeah, thanks, Miller. My thoughts in response are that I think what our current strategy is to work with the upcoming adopters as part of our collaboration and support to them to help them understand what their options are and what we think is critical and why, and try to point them to the best tool that we think fits the bill. Right now, there aren't a huge amount of options. Things like HashiCorp Vault, for example. I don't see a huge number of options in the market that would necessarily give us a choice there. But I think you're right. It's something we need to be careful to not get tripped up on in 18 months' time. Thanks.
Yeah, I would say that we should put some research into perhaps different pricing options, because I think, to James' point, if we didn't use HashiCorp Vault, then we're going to be on a really expensive option just for the base functionality. So it's either that or so like Vault with paying for some enterprise support that we need to figure out what would that be in order to support the HSM. And then the other option is it's probably going to be some cloud native, some cloud vendor solution, or it's going to be a really expensive COTS product. But anyway, I'm sure I could be proven wrong, but I would start off with some research on costs for HashiCorp Vault.
Yeah, if there's anybody in the community who we think has knowledge or expertise in this area, we'd be very happy to talk to you. Thanks.
Awesome. Thank you so much, James. David?